All right, today we're diving into a seismic shift that's happened honestly right under our noses. In just a handful of years, the entire global map of who makes our wind power has been completely redrawn. So let's break down how it happened and what it really means for the future of clean energy.
You know, for decades, if you asked this question about wind power, the answer was pretty clear. It was a story about European and American tech. But what if I told you that story has been flipped on its head? The new leaders, they're probably not who you think they are. I mean, just look at this. This single slide shows you the sheer scale of this disruption. Just 5 years back, Western companies like Vestas and GE were the undisputed champs, holding down over 60% of the market. And today, that number has done a complete 180. Chinese companies now build the majority of the world's wind turbines. It's one of the fastest industrial takeovers we have seen this century. It's just wow. Now, what's really fascinating here is that this massive power shift isn't happening in some small, shrinking market. No, quite the opposite. It's all going down inside an industry that is absolutely exploding. Get this. In 2024, the world installed a record-breaking 117 gigawatts of new wind capacity. That is a staggering amount of power, especially when you think about all the economic pressures we've been seeing, like high interest rates and inflation. It just goes to show you, wind power is not some alternative anymore. It's a core pillar of our energy future. So, how did this all happen so fast? Well, this chart is basically the answer. Of all that brand new wind power that came online last year, China accounted for almost 70% of it. Their colossal domestic market has become the ultimate launchpad, the ultimate factory floor, letting their homegrown companies build at a scale that, right now, nobody else can even touch.
And that domestic boom, it's officially crowned a new set of global leaders. So, let's meet them. Who exactly are these new kings of wind?
Right at the top of the list, you've got Goldwind. For the third year running, it's the #1 turbine supplier on the planet. And a huge part of their success came from a really smart bet they made. They shifted away from one specific type of turbine tech and poured almost 90% of their effort into a more balanced, medium-speed system. They basically found a sweet spot in the design that helped them scale up and build bigger, more efficient machines faster than the competition.
And then, on the flip side of that story, you have Vestas, the Danish giant. For years, they were the name in wind. But in 2024, for the very first time, they dropped out of the top 3. Now, to be clear, they are still the biggest player outside of China, no question, but seeing them slip in the rankings like this, it's a powerful symbol of this whole new world order. Okay, here's the full leaderboard. And it really tells the whole story, doesn't it? For the first time in history, the top 4 wind turbine suppliers in the world are all from China. Goldwind, Envision, Windy, and Mingyang have just completely swept the podium. This isn't just a lead, it is total dominance at the top of the game. But, and this is a really crucial point, while these companies dominate the global numbers, their business is still overwhelmingly local. A massive 94% of the turbines Chinese companies built last year were put up right there in China. And when they do export, they're mostly targeting markets in Asia, Africa, and South America, where price is the #1 factor. They're still finding it really tough to break into Europe and the US, where you have all these rules about local manufacturing and, frankly, deep-seated concerns about financial reliability for these massive, decades-long projects. It's like a made-in-China barrier.
This whole competition isn't just about who sells the most, though. It's also a furious race to innovate. The entire industry is driven by a simple mantra: go bigger, get smarter, and push into deeper waters.
I mean, just look at the size of these things. Last year, the average power of a single new wind turbine crossed the 5.5 megawatt mark for the first time. That's a 9% jump in just 1 year. Taller towers and longer blades mean you can capture more powerful, more consistent wind. And that's the whole ballgame when it comes to driving down the cost of electricity. And this race for better wind is literally pushing the industry off the coasts and into much deeper water. All the best shallow spots near the shore are getting crowded. That means the next great frontier for offshore wind is going to require turbines that don't need a foundation on the seabed at all. The future is floating.
So how on earth do you float a piece of machinery the size of a skyscraper in the middle of the ocean? Well, there are 3 main ways people are tackling it. The most common is the semi-submersible, which is kind of like a giant floating platform. For really rough seas, you've got the spar design, a deep, heavy cylinder that acts like a keel on a sailboat. And then there's the tension leg platform, or TLP, which gets tethered right to the seabed with super tight cables. Each one is just an incredible feat of engineering.
But all this amazing tech comes at a price, and to get that, we need to know a key industry term, LCOE. It stands for the levelized cost of energy. Simply put, it's the true all-in price tag of electricity from a power plant over its entire life. The bottom line? A lower LCOE means cheaper power for all of us.
And this table right here really lays out the challenge. Onshore wind, incredibly cheap, around $42 per megawatt hour. Traditional offshore wind, the kind fixed to the seabed, is more than double that. And floating offshore? Yeah, it's currently the most expensive by a long shot, at $181. The entire industry's mission right now is to crush that floating number down so we can unlock the absolutely massive energy potential of the deep ocean.
Of course, this incredible growth story isn't without its problems. There are some serious hurdles on the horizon that could slow things down, from supply chain headaches to a really big question about what happens at the end of a turbine's life.
You see, as these turbines get bigger and bigger, the parts inside have to become almost superhuman. We're talking gearboxes the size of a small house and main bearings that have to handle unbelievable forces for decades without failing. The supply chains for these massive components are super concentrated, and they are struggling to keep up. Plus, many designs rely heavily on rare earth magnets, which creates a huge geopolitical risk if those supply lines ever get shaky.
And then you've got the whole issue of trade policy. Things designed to protect local industries, like a proposed 25% tariff in the US, could actually backfire and make wind projects about 7% more expensive. So there's this real tension between trying to build local supply chains and trying to keep the green transition affordable.
But maybe the biggest long-term challenge is one we're just starting to talk about. This number, 60,000 tons. That's the weight of wind turbine blades that will need to be decommissioned in Europe every single year, starting in 2025. What in the world are we going to do with all of them?
Well, the solutions are starting to take shape. Right now, the kind of low-effort option is to just crush them and use them as filler in cement. A better, medium-value path is to get creative and repurpose them into things like pedestrian bridges or park benches. But the real prize, the high-value solution, is to perfect chemical processes that can break the blades down and recover those valuable glass and carbon fibers so they can be used to build new things. That's the dream, a truly circular economy for wind power.
So when you put all of this together, the huge market shift, the wild technology race, and all the challenges, a pretty clear picture of the future starts to emerge. It really looks like we're heading towards a two-track world for wind power. On one track, you've got the Chinese model. It is all about massive scale and driving down costs, using that huge home market as a launchpad to expand into developing countries. On the other track, you have the Western model. It's now forced to focus on defending its home turf with super high-tech gear, better service contracts, and yet protective trade policies. They're two totally different strategies, competing for the future of the exact same industry.
And this brings us to the final, really crucial question. The world is facing a climate crisis. We need to build more clean energy faster than ever before. So as this global market splits in two, we have to ask ourselves, will this intense competition actually accelerate innovation and make clean energy cheaper for everyone? Or is it just going to build new geopolitical walls, slowing down the one energy transition we absolutely cannot afford to get wrong? That, right there, is the tension that's going to define the next decade of wind.